and we have a very special guest. Ludovico comes from Bending Spoons, and I personally tried to have Bending Spoons in several conferences, and I've always failed. So congratulations to Ale for convincing you and your marketing department, mainly your marketing department is the hard part, that you could speak here. And we're going to see something from a real use case, how Bending Spoons has integrated AI into Evernote. Ludovico came to Bending Spoons after taking part in Lead the Future, Silicon Valley Fellowship. He was a visiting researcher in Alvar, so pretty impressive background, and the stage is yours. Thank you for being here.
Prova? Okay. Hello, everyone. I'm Ludovico. I work for Bending Spoons as an AI engineer. Today, I'm going to talk about one of our products and how we develop AI features for it. The product is Evernote, and hopefully this presentation is going to be interesting to you for two reasons. One is essentially the product part. So what features do we develop for Evernote and why do we push on AI so much? And the second is vLLM and inference servers in general, how we rely on them to self-host models and release features that work at scale for very popular applications like this one. So I'm going to start by introducing you to the app. Then I'm going to talk about a couple of AI features we developed and when we decided to use vLLM for them and when we decided not to go for vLLM and why. Then I'm going to focus on one single project, which is audio transcription, which is interesting because it's one of the few cases where vLLM serve was not enough for us to serve the model. And then I'm going to wrap up and, let's say, give the takeaways. So Evernote is a productivity app. The main feature is that users can create notes, which are documents with formatted elements such as titles, subtitles, tables, code blocks. There are a lot of them. And on top of, inside these notes, the users can store any kind of information, maybe work stuff, maybe they're students, maybe they just use it as an archive for their documents. The notes can hold also files like PDFs, images, attachments of any kind, and there are also interactive elements for productivity, such as reminders or tasks. To give you a rough idea of the scale, we have millions of active users that produced in many years. Evernote, I think it came out in 2010 almost, and we acquired it in 2023. We have now 9 billion of nodes, and every year more than 100 million of nodes are created. So that's the kind of scale we are dealing with. Here's a small video to give you an idea of the workflows that users have developed with Evernote that use every day during their, let's say, work days. Let's see if the video plays. Great. Okay, no, okay, the video doesn't work, but let's say what I wanted to show is that users can, for example, create new notes, start collaborating with another person. Then maybe they're going for a trip, so they create a calendar event. They link a note to the event. They create a task connected to the event, and then maybe they want to share it with other people. Maybe they record the conference that they've been to, and they want to transcribe it. So it's a complex app that has a lot of features, and our job as the AI team in Evernote is really to identify which workflows exist for the productivity of our users, and how we can enhance them with AI models, or even sometimes create entirely new flows in their daily workflows. Now some examples of AI features we've developed since the acquisition. One is semantic search and drag with your Evernote notes. So all the notes get converted to Markdown, and then, let's say, split into chunks, and then embedded. At the moment of query, we just embed the query, do standard vector search, and we re-rank the results to show them in the UI on the right. So here you see the keyword search results, and here the smart results which work with semantic search. And on the right, an LLM generates a quick answer, sort of like AI overviews when you search something on Google. But everything, of course, is produced using the content of your notes. This is all self-hosted, so the embedding model is self-hosted, the re-ranking model, and also the LLM producing the answer. And this was extremely challenging because when you work with 9 billion documents that come from the user is way different than when you're building a RAG for your company documents. Notes from the wild are gonna be like messy, some of them empty or like with no content at all. Also to embed 9 billion notes, it can take several days of processing with hundreds of machines. We usually use something like A100 in most cases. And the idea here for the user is that it provides value because they may be looking for something they wrote in notes years before, and they needed that piece of information now, which is dig into their accounts. And they're not going to remember the exact keywords that they use at the moment of writing. So that's why semantic search helps. And we had to put it on a separate list so that we still have a very fast keyword search working that has no delay to wait the semantic search results. And we also show the quick answer only when it's relevant, when the user asks something like a question or is looking for a specific piece of information. That's done with a simple LLM classification. But this is to give you an idea that you need to also understand the proper way to show results, and maybe it's not even the optimal one. This is just an example to show you what we've built. Another feature is the AI assistant, and this is one that works with external APIs, so no vLLM here. The idea is that you can open this window on the right and ask your assistant to do anything for you, like search something in your notes, and then it will call tools like semantic search, or it can do operations like move notes, add tags to notes, you can organize the way you like them, and any other thing you can imagine. Here, it really looks like ChatGPT, maybe you notice, and that's because we've done this in collaboration with OpenAI, like we had this opportunity to work on ChatKit, which is this UI. It's an iframe that gets rendered inside the app. And because of this collaboration opportunity, which is good for branding, because they mention you in their developer events and so on, and also because these are big models, like you cannot just use an 8 billion model to build an agent on it. We went for external APIs. Here's an interesting thing. So we don't only develop AI features inside the app, but also on websites. This is the Evernote website. And as an example, a user, like any user, even if they don't have an Evernote account, can upload a file and get the transcript. We have a lot of them. And we do that for two reasons. One is that we can maybe find potential new users for our product that maybe didn't know Evernote and found this web page because they were looking for something on the web to transcribe audios, for example. So it's partly user acquisition, but it's also A/B tests of features, let's say. So you develop something to see if people are interested before touching the product, because building a feature like this is way easier than integrating a new AI feature inside the product. No, it takes more UX shaping. And for example, we developed a website that turns text into podcasts, like notebook LLM style, and that one didn't land in the Evernote app. But it was still interesting to develop and see. So why do we care so much about AI features and why we pushed a lot on it? We don't know essentially how much AI will automate work. We don't know how AI is going to look like. But what we know for sure is that it's a major driver for productivity. If you work with coding agents or Claude with connectors, you already know that. And that means that if your app is a productivity app, you need to push on AI. We believe that the quantity and quality of the AI features that we release to the public is going to be a great predictor of our capability to retain the customers that we already have, and also the potential to acquire new ones. That's why, since the acquisition, we developed all this feature. We started from basic node summarization, and then maybe generating podcasts and diagrams from text. So now we already have an idea of how we work, from the product idea to the deployment. Maybe the product idea is a pain point, as I said, of existing workflows, or we see an opportunity to integrate the last model that came out, which does something that previously wasn't possible. But then the questions are about what model to use and how to deploy it, right? And here are the key questions. So first, if you're building an app, if you're serving an app like this, you have to ask if you're okay sharing the data of the features with external providers. And the answer sometimes is no, you cannot. For semantic search, we self-hosted everything because nodes can hold very sensitive information, and privacy is a key feature of our product. So in nodes, users can store something like work documentation, but also medical stuff, financial recipes, sometimes even passwords, something they should not, of course, but you cannot share that data with the AI providers. So when we do that with nodes content, we have to negotiate a special contract with the external providers. For example, that's what we did with OpenAI. So they have zero data retention on their end, and users, of course, will agree with that. Second, how's the quality gap between proprietary models and self-hosted models? In some cases, it's negligible. In other cases, it's not. And here we don't really think benchmarks. We think, how does it work on our our customized evaluations on the specific use case? For example, for transcription, we still use Whisper, which is definitely an old model in AI years. But for simple transcription, that's often good enough. And maybe it supports more languages than Voxtral or other more recent models. So the quality is always user-facing, not really benchmarks. Last, what are their costs and latency? So of course, self-hosted models can sometimes save you a lot of costs, and maybe they run even faster. And we're going to see an example of this later. To see some examples, for simple audio transcription, as I said, we went for a vLLM, like an inference server, because mainly cost and latency and the quality gap is small. For the embedding model, we've talked about it, right? It's privacy, but it's also cost and maintainability. Let's say that you embedded 9 billion of nodes, and you don't want to do that again because it takes weeks, and you need to be on call and make sure that the whole pipeline works right. And if you delegate the embedding to an AI provider, then if they deprecate that model, you need to do everything again, which means paying more costs, and you're not going to be in a good situation. If you own the model, maintainability is yours. For audio transcription with speaker recognition, so it's like speaker 1 said this, speaker 2 said that, we are currently self-hosting the model, but we're probably going to go for an external API because the quality gap is, let's say, consistent on that. And for the chatbot agent, we already talked about it. You're not going to build an agent with a small model. And if you use a big model, then you need to have enough traffic to justify the infrastructure cost. So here, just a list of deployments that we have, self-hosted. They go from 1 billion to 26 billion, I think is the largest Gemma 4. And they might not be the top model that just came out last week. That's because when you manage, we work in small teams and we manage large applications, so you don't always have the time to update every model. We do that only when it's justified because we save money or it's a much better model. To give an idea of the infrastructure, it's message-driven with queues. So the client puts a message in the input queue. Then there's an orchestrator which forwards the task to one or more AI model deployments. Deployment can look I can have one or two Docker containers mainly. If you use vLLM, then you're gonna have, like we have a container for that. And the Python application does the communication, maybe the pre-processing or post-processing before vLLM, or if you do just PyTorch inference, then you're not gonna have the second container, of course. The autoscaler can be configured, but essentially what we do now is that we set the maximum number of requests that a single pod, a single VM can handle in total with the batching, of course. And we measure how much traffic is that machine, let's say, processing. Okay. Then, of course, after the task is complete, it's put in the output queue and the client can consume it. Okay, now we can focus on the auto transcription project, which consisted in revamping an existing feature. So the feature was already there, and it used Whisper Large V3 as model, served with Whisper X, which is a very popular pipeline to serve Whisper. It has been there since years. And OpenAI APIs, so part of the traffic was sent to OpenAI for legacy reasons. Okay, let's not discuss it too much. The goal was to self-host everything and use vLLM to save costs and improve latency. To give you an idea of how the feature looks like in Evernote, you have two flavors. You have the plain feature, which is just text coming out of the audio, or you can have the speaker recognition. And my goal was to support both at the beginning. I put some metrics to give you an idea of the traffic. We transcribe millions of audio per month. And so saving costs on a feature like this is extremely relevant on the yearly costs of the business. I started with simple initial tests. So you run vLLM, vLLM serve Whisper, you collect a few samples of audio, and you start transcribing to measure the throughput to give you an idea. And I saw that the real-time factor, so the throughput, was 11 times faster. So I was very, very excited. But then I noticed that the timestamps that vLLM was giving me as output were not really accurate. There was like 1-2 seconds off. And so I wanted to understand why. I also needed timestamps because we self-host also the version with speaker diarization, and to put together the results of Whisper and the speaker diarization model, you need the time information. So Whisper is ideally, like the ASR part, automatic speech recognition, should output time information with words. The speaker diarization should output time information with speakers, and then you can connect them with a simple script, right? It's also useful if you want to transcribe an audio in chunks. So you take an audio, you split like of 8 hours, you split of sections of 1 hour, and then using the time information, you can essentially, since you transcribe with overlaps, remove that part and clean up the transcription. So why was vLLM not giving me accurate timestamps? And this is the interesting part, and it has to do with Whisper and its architecture and limitation. So Whisper is essentially sort of like an LLM that takes tokens in input and starts generating the output. Let's see what tokens do we have in the input. So first, the start of transcript token, which is just the start token of the text, pretty standard. Then the second is the language token. In this case, the audio was in English, and so the language is N. You can make Whisper predict that timestamp, or you can provide it as input. Then the task, in this case, it's always going to be transcribed. And then Whisper starts predicting not only words, but also timestamps. So, and one token after the other, the transcription is built. And of course, the attention is not only like self-attention between the like input tokens, but it's also there's also cross-attention on the audio. What are the issues here? The issues are that the language, you can use Whisper to detect a language using these special tokens, but it's not going to be as accurate as a dedicated language detection model. Also, you can use Whisper for silence detection. But even here, it's not going to be as accurate as the voice activity detection models, which are an entire class of existing models for audio processing. Timestamps, kind of the same. So they are they are just tokens that are predicted by the model. So it's the output of a model, and the tokens are quantized because, of course, the vocabulary of the LLM is limited. So on top of the quantization error, you have no guarantee that the model is providing like an accurate timestamp. And this is because OpenAI at the time tried to put all the features of audio transcription into one single model, but sometimes it's just not good at the same level. Of course, vLLM didn't take this into account because they care about inference speed. But if you serve this to users, then you have to dig into this stuff to understand why it doesn't work. And so my plan changed. So I thought, let's understand first how WhisperX gives me better timestamps. And the answer is using dedicated models. And then maybe my plan is going to change, right? So WhisperX has a dedicated model for language detection. It's based on Whisper, but it has a custom classification head for the language, so we can consider it as a separate model. Then there's Note VAD, so voice activity detection, which, given an audio, outputs what parts contain voice elements and cutting away the silence, essentially. Then WhisperX does a very smart thing, which is to get these voice segments and sends them to Whisper all together in a batch, essentially, filling the memory. And this way, you can unlock parallelism on a single audio file. And then, of course, you have everything to produce the transcript. So the secret for accurate timestamps was to use a voice activity detection model. For voice activity detection models, the timestamps are the input of the model. They're not the output. Like, given an audio, the voice activity detection model is going to classify every single piece of it to voice or non-voice. And then, of course, segments are a bit averaged and aggregated. So these seconds that you see here are input of the model, not the output, and that's why they are more reliable. So the new idea was to place vLLM inside the WhisperX pipeline. More complex, but at least I get accurate timestamps. It turned out to be not that complex. Of course, since like we saw before, we have two containers, one for vLLM, in this case running Whisper, and one for the rest. In this case, I put the other model, the VAD, and also the language detection model, but that's easy to do because it's small and it can run on the CPU. So there was a bit of sharing of the memory between the two models, which at the beginning was a bit of an issue. I don't know if you see the red parts, that's the error rate that I had at the beginning. But then if you reduce the amount of memory that you allocate to vLLM, you're gonna be fine. Okay, now results. So as I said at the beginning, we had speaker the recognition on and off. For these are results for simple transcription without speaker recognitions on a benchmark of like 9 hours of test audios. Then I'm going to show you also the production benchmarks, let's say. And I could see immediately that there was like a 3 to 4x improvement over the cost, throughput, and latency. Just to give you an idea, here we pay GPUs by hours. We use Kubernetes, GCP. So that's the kind of cost that I'm talking about. And okay, so here's in production. I compared the new deployment with vLLM to, before we go to this slide, if you remember at the beginning, I had 11x throughput improvement. Now I only have 3.6, which means that adding models, of course, is gonna slow the pipeline a bit. But that's fine because at least we have better quality. Then, okay, here is the comparison between the deployment cost and costs for external APIs. It depends on the contract, the cost with external providers, of course. So these are just rough numbers, but it's definitely cheaper, like 7 to 10 times cheaper. Here's the more satisfying moment of the project, which is when you see the infrastructure costs decrease because you're using GPUs way better with vLLM, and all the API costs going away. So in red, there's the OpenAI part of the traffic with the related cost, and in blue you see the infrastructure costs in dollars per day. So this is really relevant on the business, like it's hundreds of thousands of dollars each year. About speaker diarization instead, we decided that it wasn't worth it. Like as you've seen, I had to add extra models to make the pipeline work with the VAD and a separate voice, like language classifier. If I had also to add the speaker diarization, the optimization would get diluted even more, and the gains of using vLLM start to diminish. Also, like external APIs like 11 Labs offer you like great quality transcriptions. So for that, in the end, we didn't go for a production deployment. So to wrap up, essentially, the takeaways are of two kinds. One, I hope you now have an idea of how we think when we develop AI features. What do we do? Why we want to stay up to date with the AI field. And we're hopefully becoming more and more capable of understanding what features to implement and also how to optimize the deployments for them better. And inference servers are a key part because they help you on the privacy requirements. They skip you a lot of legal and privacy issues or delays. They give you cost reduction opportunities, as we've seen with the transcription project. And lastly, they're very quick to serve, like compared to how it was before with PyTorch models, when I had to clean up code written from researchers. Now it's like a single command. And this means that since, again, we have a lot on the plate, we can focus on other opportunities. And the more we can do, the best it is. So I don't know if you have any questions, but that was it.
All right, I have bad news for you because we have lots of time for questions. Who wants to be the first?
So thank you for the speech. So I think you didn't mention performance on the quality of the transcription. Is that because it works so well that, so I mean, what about performances on that?
Right, good point. So here the model was the same. Like it was Whisper Large v3 before and after. Like before I had Whisper X and OpenAI APIs serving it. After I have vLLM, but it's the same exact model. So the quality of the transcription is exactly the same. We were just making the serving more optimized. Still, we looked at some metrics to understand if this had an impact, for example, on users and also on latency. I didn't show it here, but essentially we saw that the usage of the feature didn't decrease. Actually, it increased a bit, but that was, I think, organic, not because of this change. Also, the latency was improved. I didn't show it here because it's not the crucial part, but there was also an improvement on latency. So that's why we didn't focus on quality, but maybe other metrics to make sure that the deployment went fine.
Okay, thank you.
Other questions? Well, maybe while we wait, sure, it's like the same model, but have you tried, maybe just out of curiosity, to compare this Whisper-based pipeline with a state-of-the-art 11 Labs or Gemini or OpenAI API and checked out what the difference is in terms of quality of the transcription?
Yes, so measuring that quality gap is hard when it's small. For example, in Whisper, like there are ways to build customized benchmarks and measure that for plain transcriptions without speaker recognition. but it takes time and it's hard. You can still get a feeling when you test a feature before you deploy. For example, I would say that without speaker recognition, the gap between Whisper and 11 Labs can be understanding custom words. Like if I say vLLM to Whisper that never heard that word, right? Then maybe it's gonna produce some other words making a mistake. With speaker recognition, there's a bigger gap and you notice it immediately. You notice it in the fact that a different number of speakers are detected in the same audio. So like maybe your deployment detects 8 speakers while 11 Labs 5. Then it means your deployment wasn't able to connect to understand that voices in different parts of the audios were coming from the same person. So we didn't do evaluations on a large data set. Other units in Bending Spoons did, because we use transcription a lot. And for normal transcriptions, Whisper is fine for our use cases. That's what matters. For transcription with speakers, we are migrating to that, and so we acknowledge the gap, essentially. Other models usually don't support as many languages as Whisper. So Whisper supports like 100 languages, more or less. Voxtral supports only 8. So there's also the possibility to do some kind of routing, right? So you detect the language and you say, okay, it's English, let's go with Voxtral. Then maybe it's another language way less common, let's use Whisper, or maybe 11 Labs. It's also possible. I would say it complicates the deployment even more, but and that's also why we didn't go for it yet. But for sure, if a new model comes and it serves all the languages and the quality is better, we're gonna be ready to deploy it.
Cool, thank you. Is there any more question?
Thanks for the talk. I second what you said about like the models. Even from vibe checks, you could see that everybody claims that like the NVIDIA models, what are they called? The Parakeet model are like so bad that they work for English. Like if you try them locally, they're inferior when you speak in Italian. I had more of an organizational question. Since you mentioned that also different teams deploy models for AI features, how does this work? Like how does the GenAI platform work inside Bending Spoons? Do you have centralized access? Do they vet the models for you? Are you free to host some of them?
Yeah, so right now, there's a shared infrastructure for GPU deployments, like self-hosted models. If you want to self-host your model, then you're going to use the infrastructure that I showed before with queues, which is a bit legacy, but we still use it. Now we're building a new version with that supports also streaming, for example, for LLMs. So you have very quick access to GPUs in our company. Let's say you want to deploy a model, you can do it in a couple of days, even if you're a business that never used this part of the infrastructure. You just need to connect to it and you're done. A lot of units also use APIs. So especially for the transcription, that's a good thing because you can negotiate good contracts with external providers, and then you all share the same provider. We sometimes also reuse benchmarks from one product to another. For example, maybe we acquire a new business that has transcription, and before some benchmarks were built to understand what model to use, then we can reuse the same benchmarks, which is nice, share the learnings. Yes, the big problem with benchmarks, I think, is that the data set, the data distribution is not the same, and also the metrics don't fully capture the quality of a transcript. Like, think of it, like, what's the quality of a transcript? Let's say that you measure 1% of error rate in model 1 and 1.5% error rate on the model 2. Then if you look at the benchmarks, you're going to go for model 1. But it also matters which kind of words do you miss and how. Maybe you omit words, maybe you create extra. So that's kind of the main issue.
Thanks.
Okay, thank you for the talk. You mentioned that you prefer to, in general, in this kind of application, not only transcriptions, to monitor, like to check the product feel more than the benchmarks, as a benchmark can be misleading. Do you have any, let's say, standard practices inside the Bending Spoons to monitor after the deployment these models to check the general quality that they're providing to the users? Do you do product experiments to some kind of live evaluations for this?
Okay, I will first answer about Evernote, and then I will try to answer about the whole company, because of course I know what other units do, but not as much as what happens in Evernote. When you deploy an AI model in production, it's hard to know if it's going right or wrong, because maybe the transcription is not perfect, but you're never gonna know how and when, right? You don't have logs for that, you don't have errors. So we try to do a lot of user interviews to understand what worked and what didn't. Sometimes we do A/B testing. So you deploy two models and you see essentially the engagement. Metrics are, like, you need to design the right metric based on the feature. Some features work very well for A/B testing because there's an immediate, let's say that it's, I don't know, an image generation feature, or like like before, generate diagram out of text, and you have a download button. Then I can measure how many, like, if people click on the download button, then it means that the diagram is good enough. But if I do semantic search, and I can measure maybe how many times people click on the result, they compare to keyword search. So you need to think very well what is the right metric, and it's not always possible to do. So that's what happens in Evernote. I think other units have AI features that are like better suited for automatic evaluation. For example, Remini is an app that does image editing, image generation, and that has a like download button, or you see how much the user iterates on the image before being satisfied. So yeah, every unit tries to understand the engagement metrics. The hardest to do is the AI assistant, so like the chatbot. Here is there are ways to try to you can analyze conversations to detect frustration, for example, from the user to say something went wrong, but because of privacy issues, it's really hard for us to understand what happened. So sometimes we get some reports that are anonymized about what happened, extracted with LLMs, but it doesn't work extremely well. The goal, I don't know if you guys saw it, when OpenAI released how people use ChatGPT, and they had a lot of like use cases and categorization of chats. You can do that, but at a very high level. You cannot say, you see, this tool didn't work a lot of times. Then hopefully you catch that with an error or with how many people use that tool. But yeah, you have to pray and hope that you actually get that feedback.
Any last question?
Just thank you for the talk. I had just a quick question. You say that if there is a new model, for instance, that is better than Whisper, you can replace it. How easy would be to replace Whisper in the system that you built with a new one that would be released?
Okay, so I guess like the question is about how flexible is our infrastructure.
Yeah. Like with respect to the model, yeah. How agnostic is with respect to the model?
Okay. I would say the hardest part is to understand that the new model works better. Let's assume that we know that. We already know it works better. Or we're like pretty confident and we're gonna go for the switch. Then the process is like you create a new deployment in our infrastructure, you can do that. I don't know. First, you serve it with vLLM on I serve it with vLLM on my VM with the GPU. Then I test that everything works. Then I create a new deployment in our infrastructure. I can do it in 1 day. So let's say in 2 days the feature is up. Autoscaler, I'm gonna just copy parameters of similar deployments, and I can switch. Usually you don't switch immediately. You just switch part of the traffic in increasing percentage now.
Okay, I got word that we need to close now. Ludovico, thank you very much. It was
Thank
an
you so
amazing
much.
talk.